Miss Jensen, 1.14. Almost done. Busting through this thing. 1.14. Infinite limits and vertical asymptotes. Alright. So, using the function f of x equals x squared plus 2x minus 8 over x squared plus x minus 12 to answer the following 3 questions. It wants us to identify all vertical asymptotes. So let's start by factoring. So f of x equals x plus 4 times x minus 2 all over x plus 4 times x minus 3. And we know those cancel out. And we know that when x equals negative 4, there is a hole, which is not a vertical asymptote. But we know when x makes a 0 in the denominator, aka when x equals 3, there will be a vertical asymptote at x equals 3. So that is the vertical asymptote. It is only one, and it is x equals 3. So now we're going to evaluate the limit of f of x as x approaches 3 from the left. And that is negative infinity, as shown here with our great number line. And we know when as approaching the right, it does not exist. Oh wait, no, hold on. Not from the right. Back up. But when limit of f of x as x approaches 3 from the right, it is positive infinity. Negative infinity, positive infinity, used by our number line. And we know when they do not approach from the left and the right at the same point, it is not all right. So that means the limit must not exist. Now, using our wonderful number line here that we set up, we're using the limit we're finding the left as x approaches 3 from the right, so this way. We know when we plug in any number greater than 3, we will end up with a negative value, which means that the limit of 1 minus x over x minus 3 as x approaches 3 from the right is negative infinity. Now, doing the same for number 5. I don't have a number line set up, but there's another way. So the limit as x minus 3 over x squared minus 2x plus 1 as x approaches 1, we can factor this. And when we factor it, we get x minus 1 squared. So x minus 1 times x minus 1. And when we do this, we find out that there will always be a negative value, which means that the limit is negative infinity as x approaches 1.